Okay, welcome to section 2.5 and 2.6 in pre-AP pre-cal. Section 2.5 is graphing techniques and transformations. We have hit this very hard in Algebra 2. So rather than go through every single thing, I'm going to give you a quick summary, and you can pause this video and fill in the blanks as we go. Okay, so let's take a look here and zoom in a little bit. Okay, we've left this with the old style with H's and K's. You do not have to have H's and K's if you don't want H's and K's. So I would change this to D when we're talking about vertical shifts. If D is a positive real number and is added to the output of a function, then the graph of the new function is shifted vertically up by D units, right? We know that. If D is a positive real number and we subtract it from the function, then it's shifted down vertically by D units. And these are just the graphs of what you get. If we're just using a quadratic, it's shifted up by 3, down by 4, up by 4. And notice our domain never changes, it's just the range that is affected by this. Again, pause it if you need to. Horizontal shifts. Horizontal shifts are affected by the letter C. So again, if you want to change the H's to C's, go right ahead. But if C is a positive number and is subtracted from X so that your equation looks like X minus C, then the new graph is shifted horizontally to the right by C units. If C is a positive number and is added to X, such the equation says X plus C, then the graph has shifted horizontally to the left by C units. And again, we've got our quadratic going down here. And notice that I've filled in at least 3 points on every one. So you do want to give at least 3, maybe 5 critical points. So this one's shifted right by 2 units, left by 4, and here we've combined a couple. We've gone left by 3 and down by 5. Okay, flip this over and we're going to talk about stretches and compressions. So if we multiply our function by a positive number a, and when we say positive, it means it's got to be greater than 0, but we want one greater than 1, our new function has been vertically stretched. And the way we get the coordinate points is we take every y coordinate and multiply it by the amount of a. We multiply that y value by a. When a is less than 1, then we get a compression. And again, we find the y coordinates by multiplying the y value by a. So here we've got a vertical, can we see that? There we go. A vertical stretch by 2. So normally an absolute value, stepping over from this minimum value would go over 1, up 1. But instead of going up by 1, we have to multiply by the 2. So we go up by 2. Here we have a compression, a vertical compression by 1/2. So again, normally if I stepped over 2, I would go up by 2. But I take that 2 and multiply by 1/2. That's how I get the 1. And finally, I am multiplying by 0.1, which is the same as 1/10. So it's a vertical compression by 1/10. Horizontal stretch and compressions. This is the one we do not spend too much time with this in Algebra 2, but it is good to know. And typically in Algebra 2, we use the letter B to represent horizontal stretch and compressions. And this one is not as intuitive. So if we have a value B that is multiplying the x, so the function will look like f of b comma x. Let's put f there. We multiply each x coordinate by the b value, but we multiply by 1 over b, not just b. And because 1 over b is a fraction, we get a compression. It's a fraction less than 1. If b is between 0 and 1, we still multiply by the reciprocal of this. So 1 over b will give us a number larger than 1, and we end up with a horizontal stretch. So let's take a look. We're going to use the square root function because this one's a bit easier to see when we stretch things. Here's our normal square root function. It goes through 0, 0, 1, 1, and 4, 2. Here I've got a 2 multiplying the x, so it's inside my function. So that tells me I'm going to be multiplying everything, all my x values by 1 over 2. So this is a horizontal compression by 1/2. So my x value of, normally I'd have 0, 0, so I still have that. Normally then I'd have 1, 1. that x value of 1 is multiplied by 1/2, giving me 1/2, comma 1. The next landmark point, or right on the grid lines, is at 4, 2. So instead of being at 4, 2, I take the x value of 4 and multiply it by 1/2, giving me a 2. So this one is at 2, comma 2. And over here, remember, this is just the same as 1/2 times x. 1/2 is less than 1, so I'm going to get a horizontal stretch by 1/1/2. And when we divide by fractions, we have to take the reciprocal and multiply. So that gives me a 2. So I'm going to multiply all my x values by 2, which is a horizontal stretch. So again, normally we stay at 0, 0. If I go over 1 and up 1, I take that x value of 1 and multiply it by 2, giving me an x value of 2. The y value is unchanged. The next point typically would be at 4, 2. So that would be right here. But we take that value of 4, multiply it by 2, giving us 8. So it's at 8, comma 2, because the y value does not change. So those are our stretches and compressions. If we want to take a look at our reflections, reflections simply are if your A value is negative or your B value is negative. If the A value is negative, it gives us a reflection across the x-axis. So a vertical reflection. So it flips from the top down or from the bottom up. So if we take a look at these, this has taken my quadratic and reflected it across the x. This has taken my square root function and it's reflected it horizontally, so it's flipped it across the y-axis. Okay, so again, when the x is multiplied by -1, so that means when b is negative, we have a reflection across the y-axis. And this one, this is our A value, so it is actually reflected across the x-axis. And there are your domain and ranges. And down below, we've given you somewhere we've combined different functions or different transformations. Key thing is when we're looking for a horizontal reflection, I need to factor that negative away from the x and any c value. So if I just looked at this, I can tell I've got a horizontal reflection, but I have not moved left by 2. When I factor that out, I see that I have actually moved right by 2. Okay, here's our rational function. We've vertically stretched by 3, we moved right 2 and up 1. Drawing your asymptotes, then the x value and the y value are affected by this stretch because it's symmetrical. And our final one, we have a square root, which again, we've got to factor that negative away from the x so we can see how far we translated horizontally left or right. And we've moved up by 2. So notice I've still got those same points that I've put in. And the final summary for this is the order of operations when we've got multiple transformations. So this is very much like PEMDAS. We start on the inside of our parentheses. So we do horizontal shifts first, left or right motions. We then do our stretches or compressions. Going out further, we do our reflections. And finally, vertical shifts. That's moving up or downwards. So just in case you're ever wondering how to get started, start with left or right motions after you've factored out the negative. So for instance, on this one, remember, we factored the negative away from the x before we could figure out how far we move left or right. Then we did our reflection. Next up, we did our stretch or compression, but there was none. We did our reflection, and then we did our shift of 2 upwards. Okay? Okay, let's go on to the next video to finish off section 2.6.